Here we are going to discuss about the moment of inertia of uniform and non-uniform ring or arc. Here I have taken a ring of mass m and the radius r, and now here I have explained the two methods. And important thing is that you need to also keep in mind the axis about which we are calculating. The axis is passing through the center and perpendicular to the plane of the ring, right? And this is the top view of this ring. This is the top view of this ring. And so first method is the integration method. As usual, we do the integration of the di for a continuous body, and from there we get the moment of inertia. So I have taken a point elemental mass. I have taken a elemental mass, and the elemental mass is dm and the perpendicular distance is r, because you need to visualize it. Okay, so look at this figure here. If you take a dm, the perpendicular distance, okay, the perpendicular distance will be the radius itself. And if you take anywhere this dm, if you take anywhere, this perpendicular distance will remain same, right? So that's why the di is dm r square, capital R square, where capital R is just a constant. And if I want to calculate the I for this rigid body, that will be the integration of the di, and that is integration of r square dm. Here capital R is just a constant, we can take out from the integration, right? So I have taken out from the integration and integration of dm, and integration of the dm is total mass, that is the capital M. So I is mr square. So as usual, we have calculated the moment of inertia of this ring using the integration method. Now there is the short and sweet method, the second method, by using the perpendicular transfer of the mass about the axis of rotation. So as we have discussed about the dependency of the moment of inertia. So first of all, moment of inertia depends on the distance. Second, it depends on the mass, and third, it depends on the axis of rotation. So if I transfer the mass dm in such a way that its perpendicular distance from the axis of rotation is not changing, then the moment of inertia will also not change, right? The same concept I am applying in the second method. So what I am doing, I am taking this dm and I am placing here, okay? Just you need to understand from this diagram. So let's take, this is the dm, this is the axis of rotation. So this is the dm I have placed here. Again I am transferring this dm, because again the perpendicular distance is r itself. So again, if I keep this dm here, so this is how I am collecting all of the masses. I am placing all of these masses at one place. The total mass will become equal to the total mass of this ring, and perpendicular distance will be r. Now tell me, isn't it a point mass, right? And what is the formula for the moment of inertia of point mass? That is mr square, right? Yes. So that's why directly we can say that the I is mr square. So this is the second.